All right, so graph irrational functions. If you have been keeping up with all of the lessons, then you pretty much have everything you need to be able to graph these, okay? So we know how to find the roots, we know how to find vertical asymptotes and any holes. We won't do any holes today. We know how to find y-intercept, and we know how to find our horizontal asymptotes. The only new thing is going to be showing you how to plot these on a graph, and then kind of showing you what these graphs look like. Okay? Now, I'm not sure, but I believe in one of my older videos, I showed you guys that these graphs look a little bit weird, yes? Yeah, so this is the parent function of all of these rational functions that we've been working with. You guys remember what a parent function is? Parent function is a function that has no transformations. So, for example, if I do y equals x, that's your straight line graph, your linear graph with no transformations. Goes right through the origin. For our quadratics, our U-shaped graphs, it would be y equals x squared. That's a parent function. So the parent function for our rational functions is 1 over x. Okay? And this graph, if I remember correctly, looks like so. Okay? And I kind of use this to explain why we have vertical asymptotes and why we have roots. So in this case, we don't have any roots, and we would have a vertical asymptote at 0. We can clearly see that, right? Which also means I have no y-intercept. And if you're wondering what my horizontal asymptote is, well, it's right here. At y equals 0 as well, because the bottom is bigger, yes? That's why this graph looks like that. So what happens with these graphs is they start to split. They start to freak out. And then instead what we have is we have multiple pieces for one graph. So I don't want you guys to think of this as one giant graph. You should think of it as pieces of a graph. Okay? Now, the only new thing on here is your rotation check, yes? And I'll show you 2 different ways to do the rotation check on this. The biggest thing to remember is see how this is negative? I mean it's negative as of the fact that the y values are negative. It's in the bottom quadrant, right? So since it ended as being negative when I approached an asymptote, then that means on the other side it has to be positive. And this is true for all of your roots and your vertical asymptotes. Every time your graph hits a root or a vertical asymptote, it's going to change from negative to positive or positive to negative. And that's going to become the main focus for us sketching these graphs today. So we went over the homework on number 13, so I don't really want to graph anything with holes. I'm just going to pull stuff right from your homework, if that's okay with you guys.
Sure.
I figured you guys would be okay with that. No, on day 6, the day 7 that you guys already did. Yeah, because remember I uploaded the answers? I just copied down my answers. Alright, so on this one, I listed the roots. We obviously have 2 roots because it was x squared, -4, and 2. I put it in proper format. Our vertical asymptotes, we have 2 of them, -3 and 3. We had no holes. Y-intercept was -8 over 27. And then because they both were squared for the highest degree, I just looked at the leading coefficients, which is how I got a -1/3. Okay? Any questions about any of these values before I kind of jump into graphing? All right. So, we're literally going to be sketching graphs. So to be able to sketch it, I need to have an x and y axis. Don't waste your time putting in a whole bunch of tick marks, okay? We're sketching. Easier if you just leave a blank and just place numbers in order where you need them. Alright, so we're going to plot the roots first. And these are x-intercepts, so they touch the x-axis, right? They are literally points on the x-axis. That's why we're writing them as a point. Okay? So -4 is probably right about here. And a +2, maybe right about here. Did I make those dots large enough for you to remember that they're points? Alright, and then vertical asymptotes we dash. Because they are not a part of the graph. They're just there as a way to remind you that the graph is approaching that it can't cross over. So if you were to put this on your gravity calculator, it won't show you the vertical asymptotes. It will just be a gap there. That's the nice thing about sketching. So -3 is maybe, what, right here? Right about, maybe? And the +3 is over here somewhere. Questions on how I did those? Seem fairly simple? Alright, good. Alright, but don't have to worry about any holes. Alright, y-intercept. I know it's a fraction. It's less than 1, right? It's pretty tiny. Okay, well, here we go. There's my y-intercept. Usually I would have you label it, but, well, let me see if I can fit it on here with my stylus. It's always a little bit harder with the stylus. Alright, and then my horizontal asymptote. So my horizontal asymptote, -1/3. -1/3 is larger than -8/27, right? If not, correct me. Okay, so y equals -1/3. Alright. That line was really crooked. Oh well. Alright, so if you are able to plot all of this, you pretty much just did 90% of the work right here. Now, I recommend that you might want to start using some colors for your homework, just so that it won't get so messy with your pencil until you guys get used to seeing these. Alright, so here's the thing. I'm going to show you guys some basic logic about these, and then I'll show you how to kind of test it out and see if you're right. Okay? So let's just look at this section here. Okay? My graph can do multiple things. It can go like this. But would that make sense? What does my graph have to touch? My x-axis, my root, yes? So if I put it here, then it ends up being stuck because the ends of my graph can't cross over this green line. So it can't be here. Does that kind of make sense? Okay, what if I drew it like this? This is a fun one, so I get graphs like that. Does that make sense?
They're not going to cross that green.
Yeah, it's still not going to cross over the blue, and the issue right here is that it will keep going, because that's what the arrows mean. And don't be cute and just leave your arrows off and go, well, I left my arrows off. No, it doesn't work that way. This graph would eventually go through the x-axis. I mean, not the x-axis. The vertical asymptote. Okay, so it can't go like that. So there's no way for my graph to be right here. We okay with that? All right. Well, so when I know it has to go here, oops, that was not my pointer. Then we need to figure out how to sketch it. So do you think it goes like this? Does that look right?
Yeah.
I mean, it's going through the root, but what should this part of the graph be doing?
Up? Shouldn't that part of
It should be going up, right? It's supposed to get really close to this vertical asymptote. Not only that, but if I did a vertical line test, would this even be a graph? It's not a function, is it? Okay, can't do it that way. All right, what if I go like this? Well, what would happen to the end right here? Oh, it hits the green one. Oh, well, darn. It can't go through it.
Would it go on the other one? Like up?
Yeah, go up. But like,
Maybe like this? I'm just showing you guys all the different types of answers I have received in the past, 9 years when teaching this unit? I know, but I want to explain it. So look, this graph, the end has to follow the green line. This part of the graph cannot cross over. Just this part, okay? It also has to go through the root. Agreed? Okay, remember what I said, that every time you hit a root and a vertical asymptote, it switches? So notice that we are negative here. What happened when I hit the root? It became positive. So after you get the initial part, the rest of the graph is actually fairly easy. Because since I ended positive, where do I start over here? Negative. Okay, and I know it has to go through my y-intercept and here, right? I hit a root, so I stopped. So once again, because I ended positive, the graph has to pick back up negative. That make sense? This is where that split happens.
Okay, I got a question.
Sure.
Okay, how come on this one you just start with a point?
Ah, good question. That's because there's multiple ways to possibly write this. Okay.
Okay, well, why did you go through that -8
Because that's the y-intercept. Remember, the graph has to cross over the y-axis at the y-intercept. Okay. All right. So I stopped at the root because what happens at a root? Since it was negative, my graph should then be positive. So it starts to look like those snake graphs that we saw. I can't hear you.
So we don't want those.
No, this is right. That's right. I mean, because I hit a root, so I know I had to switch from either negative positive or positive negative. Since I was already negative, I just wrote it keep on the positive side. All right, I ended positive, so what should happen over here? It should be negative. So it's either going to be here or it's going to be here. Because it has to be a negative side, right? All right, well, let's test some theories out. So what if I draw it like this? No, that's not a function. Okay. What about like this? Huh? What do you think of that last part I drew? What did I just create by drawing the graph like that? What did it do right here? Oh, I made another root. Is there supposed to be a root there?
No.
Nope. Okay, well, I can't draw it that way then. See how this is all kind of connecting?
Well, okay, so why did you draw that one right there? Did you have to draw that one?
The one I just erased?
No, not that one, though. The second one that you drew.
Yeah, because the graph has to approach this red line.
Okay, so there needs to be 3.
There will be 3 parts here, yeah.
Okay, so how come the second one can go through the green one? Yeah.
Ah, okay, so remember I said the horizontal asymptotes restrict the ends of your whole graph. So, this is considered the middle part of the graph. This is the end of the graph. And the one that we're trying to do over here is the end of the graph. Very good question. I was going to talk about that after I drew it, but it works now. And we'll get into more of that when I see you guys on Tuesday, because I'll be talking about end behavior again, which is your horizontal asymptote. All right, so the last part actually has to look like this. It's in this small little section here. That's the only place for it to fit. So notice how when one goes up, what does the other one do? It goes down. And it does that every single time for your vertical asymptotes, you guys. That's where it splits off. That's where it goes, oh no, I can't exist there. And then it starts running. And if I was to zoom out, this part right here would get closer and closer and closer to -3 until it just isn't. So it could be -3.0000000000000000000000001, and it would still be over here. You guys like that?
Sure.
I practiced that. Or on this side, this graph going down, it could be a -2.99999999999999999999999, and it will still be on this side. See the difference? But as soon as it hits -3, the graph doesn't exist. That make sense?
Yes.
Guys, that's all you're going to remember is the 0.0s and the 0.9s, huh? Same here. It could be 2.9 forever and ever and ever. Be really, really close to this 3. But as soon as it actually is 3, the graph doesn't exist.
So it's never going to
It will never be 3. That's why I had you guys find those excluded values in the beginning. Okay? Ready to do another one? Yes. All right, let's graph this one from your homework. So I'll give you a moment to write it down. We obviously don't need the domain, but like I said, I just copied this from your homework. So I'll give you a few moments. All right, so before I start plotting things, a couple of things. We don't have any roots. And I haven't done too many examples where this happens, but you know how I told you to set the numerator equal to 0? Well, does it make sense that 1 equals 0? Since it's an untrue statement, there's no roots. That make sense? Okay, just want to make sure. I've had a few text messages about that. Vertical asymptotes, we had 2, and since we didn't have any roots, we're obviously not going to have any holes. Y-intercept was 1 over the negative 6. And then my horizontal asymptote, because my highest variable up here was x to the 0 power, 0. And this one is x squared. See how the bottom is larger? So it's y equals 0. Do you guys understand why it's y equals 0? What's happening to your fraction as the denominator gets larger? The whole fraction is getting smaller. So if your denominator is increasing to infinity, then that means that overall your entire value is getting tinier and tinier and tinier, right? Yep. Until it becomes 0. That's why the horizontal asymptote is 0. Okay, just thought I would give you a little tidbit there. When you guys did sequences and series in 9th grade, according to algebra, they used to actually talk about that, and now they don't. They wait until this year to start talking about that stuff. So, all right, let's plot this. This time I'll have a little bit more room. I'm excited. I like having more room. All right, so we have no roots, so I have no blue dots. Vertical asymptotes were at 2 and 3. So since I don't have any roots, will my graph that I'm sketching ever touch the x-axis? Will it? No. So don't let your pencil draw the graph through the x-axis, okay? I always love it when everybody has everything all correct and then they just sketch a whole bunch of roots that they're adding in. And I'm like, no. You just ruined it. All right, here's your horizontal asymptote. And then our y-intercept was somewhere down here. A negative 1 over 6. And I think that's it. Okay. All right, so right away, I know where this graph has to start. Is it going to start negative or positive? What value gives us the hint? The negative, what is it? Where's our negative 1? Where does my graph start on the left side? Do you think it's going to be under the y-axis or above the y-axis? Why do you think under?
Above.
Why do you think above?
Because it can't cross the
Oh, yeah.
So remember, the piece has to touch the purple value, the y-intercept?
Yeah, so it'll be under.
It'll be under? What do you guys think about that reasoning? All right, now remember, your pieces of your graph, because this is on the end, right? Has to do 2 things. It has to approach that green line, like come close to it, and it has to come close to the red line, right? So the issue is that if I draw it up here, what did I just create right here? A y-intercept. Where should my y-intercept be? Yeah, so you see how this kind of gives you a clue of what it should look like. See? That's why I have you guys plot on the information. That's why we spent like 3 class days just finding all these characteristics. Now, since we ended negative, this part right here has to be what? Positive. Okay, so I know my graph is here. But the issue is, how do I sketch that? Well, if I draw a snake graph, then I create a root. If I draw it like this, I still create a root. An L? All right, if I create an L, what happens to my graph right here?
It's still.
It goes through my vertical asymptote.
Can you do like this, Miss Sykes? Like
Oh, up? Sure, that looks good. So, see how I had a root on the other example? So it gave us that snake graph, right? In this one, we didn't have a root. It was stuck between two vertical asymptotes. So that gives you that U-shaped graph, okay? Because we need it to stay positive, and we need it to come close to both of these red lines. See how that kind of makes sense there a little bit?
Yeah. I see.
So we ended positive, so we must start this one as a negative. Here we go. That's all it is. Alright, so this was number 7 from your day 7 homework. So I'll give you a moment. Remember, you don't need the domain right now. I mean, the domain tells you how many sections you're going to have. Can you guys see that I'm already going to have 2 sections here?
Yeah.
So the domain is kind of a great hint of how many pieces of graph you're going to have. I know you guys are copying, but just look over here for a second. How many pieces did I have for this domain?
3.
How many pieces of graph did I have?
3.
Oh, amazing. Just thought I'd point that out, you know. Alright, so on this one we do have one root, and we do have one vertical asymptote, okay? So let's go ahead and plot this.
Can I run against it real quick?
Yeah. Alright, so our root is at 2, so I'll make this fairly large at 2. And vertical asymptote is at positive 4. And then our y-intercept was at a negative 1. Okay. All right. Take a moment. I want you guys to sketch lightly how you think this graph is going to look on your own. Just a moment, you know, we'll take a moment. I did forget to do that. What was it at, negative 2? There you go. All right, what do we think? How does this graph look? You want to try sketching it?
Do I want to try? No, I want to tell you, and I want you to tell me whether I'm right or not.
Okay, so you're going to have to be very detailed in your directions. You ready? Go
Yeah, I
ahead.
know that.
Where am I going to put my
So-
stylus?
First, I think you need to, because you said it has to be not, it can't touch the green line, the ends can't touch the green line.
Okay.
But they can't touch the red line. either.
Okay.
So I think it's going to be like straight line, go through the
Okay, so I'm right here. Where do you want me to move?
through the negative 1,
Through the negative 1, okay.
through the 2,
Through the 2, and then what?
up.
Up like that?
Yeah.
Okay. What do you guys think?
That works.
Yeah, I mean, I touched the y and the y-intercept. I went through the root, and it's approaching my red and my green line. Yes?
Oh, yeah.
Since I ended positive, I must start.
Negative.
Oh, so it has to be here.
Yes. Oh, we're over.
See? Alright, so now the big question that pops up is, Miss Sykes, I have a graph where when I created it, I had a vertical asymptote over here. And I didn't have any points. How do I know if it's positive or negative? If you're not given a root or a y-intercept that will tell you whether it starts positive or negative, pick a point. Plug it into the formula. See if you get a positive value or a negative value. Look, if I pick a value over here, let's say negative 1, okay? And if I was to plug it into this problem, I'm going to get a negative answer. See how that works? If I pick any number, so maybe I pick a negative 6. If I pick a negative 6 and I plug it in here and simplify it, I'll get a negative answer. So, I was looking for an example of one. I think I have one in the video that's already posted. But I'm posting both of these videos for you guys.
Oh, is it in like the
I don't remember. That's why I'm talking about it. Okay, same over here. If you couldn't figure out whether your graph was supposed to be positive or negative, pick a value that's bigger than 4. What's a value bigger than 4?
5.
Alright, so I bet you anything, if I plugged in 5, I would get a negative number. Well, let's do that. 5 minus 4 is? Alright. And negative 2 times 5 is? Negative 10 plus 4 is? And negative 6 divided by 1? Oh, look at that. It's a negative number. That's why the graph is negative. See that? So those are just little tips and tricks. Some teachers will make students do tested values every single time. If you can see it, then write it. Okay? I'm not going to make you test values if it's unneeded. Make sense? Okay? If you want more examples, definitely look at the other video, because I know that they had me create a weird example, and it ended up bringing up a case that I tried to avoid with you guys. It was just kind of an interesting graph to look at.
So it's not our homework on our homework.
Oh no, I wouldn't put one of those on your homework. It shouldn't be. I'm pretty careful about catching things like that. Usually. It just happened with that because they asked me to create an instance because of their question that they had. And so it created an issue that wouldn't have been there if I had, vetted my example in the future. Okay. All right, any other questions over this? My recommendation is to go through your 8 problems, find all your characteristics, and then go back and graph. It'll make your life a whole lot easier if you just have a list to worry about, okay?